So transforming equations. Does anybody know how? What do you think we mean by transforming equation? First of all, yeah. Changing them, right? So why would you want to change an equation? By the way, why not leave it alone? Why would you want to even change the equation? You know what I mean? Why would you even need to change or transform equations? What's the whole purpose of this? Anybody? Yeah. Yeah, it'll be easier and simpler. In other words, if we have an equation, many times we want to transform this equation so that you have what by itself? Yeah, the variable by itself. So you can actually figure out, this is how you solve things, basically. You know what I'm talking about? So this is what I mean by that. First of all, let's write this down. For example, look, I have this equation. Do you think I want to transform this equation at all? This is a very simple equation we like, because no, we don't want to transform this because it says x equals 2. We know what x equals 2, that's right? But if I have something like this, if I have x plus 1 equals to 3, you might want to transform that equation, wouldn't you? Does anybody know how to transform that equation? Mimi, what do you think?
Well, you subtract 1
From
both sides.
both sides, right? Then you would end up with x equals to 2, wouldn't you? So like if you have some equations, right? Many times you want to transform it so you get the variable by itself. Another word for that is what? Yeah. No, not quite. Yeah. Simple. We don't simplify equations. What do we do with them? You solve. You solve for the variable, right? So basically, when you're transforming these equations, right? The end result is you want the variable by itself. We're basically solving for that variable. Does that make sense? Again, if I have this, 2x equals to 4, you probably don't want to leave that equation that way. You probably want to transform it, right? How would you like to transform 2x equals to 4? Yeah. You would divide both sides by 2, right? And you would end up getting x equals to 2, right? So do you see how all of these three equations, they all have the same solution? By the way, do you think what we call all these equations that have the same solution? We say these equations are? Yes, sir. Equivalent is correct. Very good. So write this down. When these equations have the same solution, we call these equations equivalent equations. That's when the equations have the same solution. Okay? Write that down. Oh, wait. So if you think back, I think a lot of you already know. Let's say I have this simple equation, a equals to b. Then, oops, you can't see it yet, sorry. If a is equal to b, then could we add both sides of this equation by same number? How many people say yes, you may do that? In other words, does the solution change if I add both sides of this equation by same number? In other words, would that be equivalent? How many people say yes? How many people say no, you can't do that? Actually, you can. It's fine. They're equivalent. If you add same number to both sides of an equation, right? Don't you get the same answer? Yeah. Didn't we do that before? Like when I have x plus 1 equals to 3, you added both sides by what? You want me to go back up? Here, take a look at this example. When we had x plus 1 equals to 3, we could add both sides by -1, couldn't we? And don't we get x equals to 2? So when you add both sides an equation by same number, does the answer change or does the solution change? In other words, are these equivalent? Yes. Yeah, this is fine. Isn't this what you do to solve equations? Right, guys? Okay. So there's a name for this. Actually, this is a property. Do you guys remember property of equalities? This is one of those, property of equalities. It's called something property of equality. Anybody want to guess what this might be? When you add the same number to both sides of an equation, you get the same answer? Yes. Addition property of equality is correct. Do you guys understand what I'm trying to say? Yeah. Isn't this what we do to solve equations? Right? Sometimes we could add both sides by the same number to both, right, an equation, so that we get the x by itself. Right? So there's another property of equality. The next property is, anybody want to guess what the next property is? Could we subtract both sides by the same number of an equation? Just like here, if I have x plus 1 equals to 3, could we subtract both sides by 1? Yeah? Do we get the same answer? Would the equation be still equal? equivalent. Anybody want to guess what that's called? Take a wild guess. If this thing is called addition property of equality. Yes.
Division properties of
Almost. These are property of equality again. In other words, these equations are sort of equal to each other, right? They have the same solution. So instead of addition property of equality, it will be something property of equality. Subtraction property of equality is correct. Does that make sense? Okay. By the way, do I like addition better or subtraction better?
Addition.
Yeah, because subtraction is really adding the
Opposite.
That's why I put a star. I mean, not star. I put a heart here because I like addition better. So you know, the subtraction property of equality, you could still use it, but I like addition property of equality a lot better because you could always add the opposite. And addition has property called commutative property of addition, right? And associative property. So it's a lot better because subtraction don't have those properties, do they? Okay. So keep that in mind. Next, if I have again a equals to b, a very simple equation. Is it okay to multiply both sides by the same number?
Yeah.
Does it change the solution at all?
No.
In other words, are they equivalent?
Yeah.
Yes. Anybody want to guess what this property is called? Take a wild guess. The first one was called addition property of equality. Second one was the subtraction property of equality. Take a wild guess in terms of what this is called. A lot of you, okay. How about Kevin? You want to take a guess?
multiplication property.
Exactly, you got it. It's called the multiplication property of equality. Right? So you have exactly, where'd you get that, right? So if you add both sides by the same number, subtract both sides by the same number, multiply both sides by the same number, they're all equivalent, right? This is how we transform equations, correct? And a lot of you know already how to do that, right? It's called the multiplication property of equality. Is that okay? And of course, if I could have this, anybody want to guess what the last property of equality might be called? How about Brandon? What do you think? You got it. It's called the division property of equality. So if I have A equals to B, then anybody want to say how would you read? Michael?
A divided by C.
Yeah.
B divided by
Exactly. A over C. I wrote it as a fraction. A over C is equal to B over C. Of course, C cannot be what? Zero. Okay, you all know that. So and of course, Brandon said it. The answer, is called the division property of equality. By the way, do I like division better or multiplication better?
Multiplication better.
Yeah, because dividing is same as multiplying by the reciprocal, right? Does that make sense? So, and again, multiplication has nice properties called. Which property does multiplication have? Where division doesn't have? Yes. Commutative and associative. That's why I like those better. Okay. Good. Go ahead and write it. Here's an example. X plus 7 equals to negative 9. Now, what can I do to transform this equation so that I get x by itself? In other words, how do I solve this? Okay, it's sort of easy. Something you've been doing all this time. It's just we now know the name for these things that we're doing here. Carly, what do you think? Subtract 7 from both sides, or since I like addition, could I do this by adding? I could add both sides by? Yeah, I like to add. So I'm going to add both sides by negative 7. Is that okay? So I basically add both sides by negative 7. What do I get on the left side here? Lindsay?
You get x.
I get x. On the right side, it's negative 9 plus negative 7. Sammy, what do I get? Negative 16 is correct. Easy enough?
Yeah.
Do you see how we transform the equations? Do you see how they're going to have the same answer? Because it doesn't matter if you add both sides by the same number or not. You get the same answer. Yeah, question? Yeah, right. So, yeah, if you want to subtract both sides by 7, that's fine. But I like addition, so yeah. But do you see why I did it that way? Okay. Actually, it's a good idea to actually add by negative 7 rather than subtracting 7. Later, when this equation gets a little bit more interesting, okay, you want to be able to do them in any order you want. So, because addition have commutative, it's a good idea to keep it as addition. Try to do that, okay? Don't subtract or divide. Please add or multiply both sides by an equation or with the same number, okay? Good. Also, some of you might not write it this way. It's okay to write just adding negative 7 underneath, and many of you may be, right? Many of you might know that this is, when you add them together, you get, right, if you do it this way, Is it negative 9 minus 7 or is it negative 9 plus negative 7? Plus. Okay, so please don't make that mistake, okay? Because people see that subtraction. So this will be negative 9 plus negative 7, right? You're adding both sides by negative 7. So I wrote this because people sometimes do that and that you get it wrong answer if you do that. Okay. Now sometimes you may get an equation this way. So today I'm just going to talk about all the additions. Tomorrow we'll talk about how you divide both sides by same number. Okay. Yeah, this is absolute value. Okay. It doesn't. It's not 1 times 1. Okay. It's absolute value of x plus 4 equals to 13. What do you think I need to do? Yes, one person knows? Alright, I'm more. Chris, what do you think? I don't like subtracting. Add what to both sides? I add negative 4 to both sides. Okay. So when I add negative 4 to both sides, just notice what I'm doing. I'm adding negative 4 to both sides. Who can tell me what I get on the left side? Yeah, if you have absolute value by absolute value of x, you want to keep that by itself. Yes, one person knows? 2? Okay, is this too easy? Okay, Samuel Lee, what do you think? I get 9 on the right side and left side I get? Do I get x or do I get absolute value? Absolute value of x is correct. I'm done, right? No, am I solving for absolute value of x or actual x? X. So can somebody tell me what the answer of this might be? Turns out there are 2 ways for this to be true. Camilla, what are 2 ways? X could be negative 9 or positive 9. Or you could write it as a set. Does that make sense? Do you guys remember learning about absolute value last time? Okay. Yes, sir.
Can you put plus minus 9?
Yes, you can, but do I want you to do it that way? No, why? Because people think positive or negative 9 is one number. If you write it that way, people think a number can't be positive or negative at the same time, right? Other than, right? Well, maybe 0 could be. I guess 0 is neither positive or negative. Okay, may I move on? If I have this equation, 2 equals to 6 plus absolute value of x. Of course, we want to get the absolute value of x by itself. So what do we do here? Same people all the time. Come on, somebody that have an answer. Who haven't I called? I haven't called. Eugene, what do you think, sir?
Do minus x on both sides.
Minus x on both sides. Actually, absolute value. You don't have x. You have absolute value of x. So you probably don't want to move that thing around. Let's get rid of the numbers around it. Is there a way to get rid of the 6? Because if you get rid of the 6, you have the absolute value of x. Yeah. You what?
Minus x on both sides.
Oh. Well, we don't have x. We have absolute value.
I mean minus 6. Right?
Minus 6, exactly. But I don't like subtracting. I want to add. What can I add to both sides?
Add minus 6.
Exactly. Negative 6 to both sides. Then, class, on the left, what is 2 plus negative 6? It is negative 4. Then, on the right side here, of course, these cancel out. 0 plus absolute value of x is still absolute value of x. Right? Yes?
I thought the absolute value of something can never be negative.
Hold on to that thought. So, can I rewrite it this way? Can I write, what property am I using right now? Absolute value of x equals to negative 4. What property is this? Who remembers? Eric?
Is it transitive property? Or
No, it's not transitive.
symmetric.
Symmetric property of equality is correct. I just wrote it this way because we're so used to having absolute value on the left, or x on the left side, right? And then a number. And Tajwar, what do you think? The answer is what? You just said it. Can you have absolute value of number and come out to be negative? It's impossible, isn't it? You can plug in any numbers you like in x. If you take the absolute value of it, it's always going to be positive. What do you think our answer is? One person knows? Come on, we talked about this before. Oh, a lot of you. Okay, how about Royce? No solution is correct. This is your answer. Yeah, that's no solution because, yeah, there's no number you could plug in x so that the absolute value of x comes out to be negative. It's impossible. Does that make sense? You guys remember this? Yes? Okay. Yes. Yes, it will work if you have a negative in front of it, but we don't have any negative. So after you clear everything, right, in front of the absolute value, if you have the absolute value by itself, right, if you have absolute value of x equals to some negative number, answer is always going to be no solution. Of course, if you have negative, yeah, you can multiply both sides by -1, but we don't have that, right? Does that make sense? So if you have the absolute value of x by itself equals to some negative number, it's impossible. This is not possible at all. You guys remember this? Yes? And tomorrow we're going to talk about how we could multiply both sides by the same number. Do I like division? We could always multiply by the reciprocal of it, okay? So tomorrow that's what we're going to talk about. Any question? Yes, sir?
I know from multiply with the isn't it easier to divide?
Yeah.
It would be like learning how to-
But multiplication has, remember I told you, there's nice property. Okay? I mean, any question? All right, good.